Hi Zach, this is the video to go over the answers from the continuity video I posted like 2 weeks ago. You remember this from the last answers video, right? I'm going to write down the answers, and if you get them wrong, you can skip to the parts of the video that explains them. If you get them all right, no need to watch this video. I just have a few things I want to go over before we actually jump into the answers. I feel like I didn't give a good enough explanation of why vertical asymptotes and holes happen, so we're going to start out with that. Vertical asymptotes happen when the value in the denominator gets really, really small. And when we divide 1 by a really, really small number, we get a really, really big number. Hence, as things get really close to 0, aka really, really small, the value of the function goes up to infinity. So if we have 1 over x, for example, we have 1 over a really small positive number on the right side and 1 over a really small negative number on the left side. Hence, we get a vertical asymptote up to positive infinity on the right and down to negative infinity on the left. When we take 1 over x squared, we have 1 over a really small positive value squared on the right side and 1 over a really small negative number squared on the left side. However, when you square both a positive and a negative number, they both end up being positive numbers. So, the vertical asymptote goes up to positive infinity on both sides. We get holes when at a specific value, the function is equal to 0 over 0. 0 over 0, as you can imagine from all of your algebra training, is undefined, but not in the same way as the vertical asymptote, because the limit still exists as if the function was continuous. We have x squared minus 3x over x minus 3. We can easily see that x minus 3 factors out of both the numerator and the denominator. But even though the function is equal to x, there must be a hole at positive 3, because it's clearly not defined at positive 3. We have 0 over 0. Jumps, as you can probably deduce, usually happen when you have piecewise functions that just don't meet up, but they can also happen when you have absolute value functions. Our first example was x cubed plus 15x squared plus 62x plus 72 over x squared minus 5x minus 36. The first thing I am going to do is I'm going to factor the denominator. That numerator looks hella scary. No way. So, the denominator easily factors into x plus 4 times x minus 9. Now, we can kind of assume that I'm going to try to be a little bit tricky with you. So, we can guess that one of the roots in the numerator is probably going to be one of the ones in the denominator, because holes and continuity. Since the numerator has entirely positive addends, let's guess that x plus 4 is a factor in the numerator. So, we're going to use some synthetic division. Let's go over how to do that real quick. The easiest way to divide by a factor is to write out the coefficients of all of the terms. We're going to write negative 4 up in the corner because that's what's going to make x plus 4 0. And we are going to bring down that 1. Then we are going to multiply 1 times our factor, negative 4, and add that to our second coefficient. That gives us positive 11. Multiply positive 11 times negative 4. Negative 44, add that to 62. Positive 18. 18 times negative 4 is negative 72. 72 plus negative 72 is 0. So, x plus 4 times x squared plus 11x plus 18 are two things we know are in the numerator. Now, x plus 4 is in both the numerator and the denominator, so there must be a hole there. Then we can easily factor x squared plus 11x plus 18. That's x plus 2 times x plus 9. X minus 9 is in the denominator and not in the numerator, so we can assume that that is going to be a vertical asymptote. Everywhere else, the function is continuous. So, function has a hole at negative 4, a vertical asymptote at 9, and is continuous on negative infinity to negative 4 to 9, and 9 to positive infinity. On to question number 2. Here we have a piecewise function, so mostly what we're going to be checking for is whether or not there's any jumps here. The jumps are going to be at the points where it switches function. So let's check at the points negative 2 and 1. At negative 2, x is equal to negative 2. X squared is equal to negative 2 squared, or 4. Negative 2 does not equal 4, so there must be a jump at x equals negative 2. At x equals 1, x squared equals 1 squared equals 1, and x cubed equals 1 cubed equals 1. 1 equals 1, so there's not a jump there. However, the less than and greater than signs are not closed, So the function is not defined at x equals 1. So there's actually a hole here. There is a hole at 1 and a jump at -2. The function is continuous on -infinity to -2, -2 to 1, and 1 to positive infinity. Onto my favorite, the challenge question. Like the last question, if there is going to be a discontinuity, it's going to be at that point where the two different functions meet. We have to try to get the two functions to be equal at this point of x equals -2. The way to do that is to plug in -2 to both of these equations. We have -2 squared minus 4 is equal to -2 cubed times, I made a mistake here, 8 times -2 squared minus a times -2 minus 32. I think you can do the rest of this. So we get 8 equals 2a and a equals 4.